Okay,
Great.
we are recording. Go ahead, Nick.
All right. Good to see everyone. Today we'll just be going over some tools that we developed for TIMCON and beam operators to predict and prepare the beams for the next shot, given session leaders asking you for generic things like raise the beta by 20% or give me 1 megawatt more power or something like that. And hopefully the tools are of use to everyone. We can of course develop them, so at the end I'll be happy to hear any suggestions for improvement that you have. So the tools that I've developed are and Teresa and other people have contributed as well, are in OMFIT. And so we'll start by looking at the screen here and find all the many screens that I have open. Great. Can you see my screen?
Looks good.
Okay, so if you just Google OMFIT or type in omfit.io, you'll get to a website, and you can see all the different modules that are in OMFIT. There's one called TIMCON to manipulate the D3D beam timing. There's a short description here, and you can find some resources. There's a D3D NBI operator notebook. If you don't know about this, it looks like this and has an overview of what we do with the beams, the TIMCON timing interface, where you can manually program different timing for each of the beams. And then there's also a plasma control system interface where you can do beam feedback programming. So if you want to keep some set beta target, for example, then you would use the PCS beams. And so it just goes over what I thought when I learned this, what I thought was useful. And then since then, other people have contributed as well. And so I think it's a useful resource. You're encouraged to come and add in things that are missing or make a comment of things that we could improve, etc. It's got tips for doing remote ops and where the TIMCON files are located if you ever need to find those, etc. Some things that I find useful that I kind of come back to a lot are some rough scalings of the power and torque with voltages, for example. Although the OMFIT module will do this better for you now. This is how I used to just do it in the control room in my head. And then also different beams with the different diagnostics that are on these beams. So, the 30 beams have charge exchange recombination for measurements, and there's voltage requirements for good measurements there, etc. And so, if there's something missing, definitely document more about the diagnostics. I find this section helpful when session leaders are saying that they want certain power, but then they also want certain diagnostics. Okay, so then soon to be posted on that OMFIT website is now this tutorial for the module that we're going to use, which has some information about the scalings and stuff again, but also getting started and how to open OMFIT and use this module. And we're just going to do this live, so we don't have to go through it much. Okay, so let's get started. No machine. So I'm on a no machine connection to Iris. You could also do this on Atom through Boulder if it was a run day, for example. So you're gonna want to go onto Iris, and I'm gonna just purge my modules and load OMFIT. The unstable branch is always the most up to date, and I like up to date things, so I'm gonna use that. And then you can run OMFIT. You can then proceed to open whatever module you want. I know the module that I want, so I'm going to do -m TIMCON, and it'll just open that module right off the bat for me. Take a second. Okay. Is this a reasonable size for everyone? Hopefully you can read the text.
Yeah, that looks good.
Text larger. Oh no, I'm a bit frozen. What did I do? I clicked too early. Okay. Okay, so like I said, you could do file, import module, and get your TIMCON, but we have it here. So this is a typical OMFIT setup with your OMFIT tree here. Console is going to be where useful things are printed. Command box, you can do Python. Things. Okay, so a module, there's a submodule called D3D Beams that does all the heavy lifting on the calculations. We'll get into that. It has inputs and it has outputs. If we double click on the module, it has this nice GUI interface, and it's going to ask you to interface with TIMCON, which has an ASCII file format. And so you can load a TIMCON file from a shot. And so I'm going to do 182.639. It's one that I was working on recently. And so when I click that, you can see that it's gone to PT data and collected a bunch of information about the beams and then stored it in this 182.639_OMFIT TCMB file. That file is loaded into the tree here as an input for our module. You can select it and do a spacebar to open it in your favorite editor and go to town, changing things if you want. Or you can look at it delving into the tree, so it has each beam, it has whether or not it's enabled, what's its status, different phases, start times, on times, etc. So if you've, I'm assuming that everyone here is a beam operator and has seen the actual TIMCON interface, which provides a GUI for changing these different phases, on times and off times, and creates a waveform. That waveform was created for this shot, and I've loaded it, and so I can check it. It looks like this. So a pretty typical case with 30 left on regularly for MSE, and then a series of beams to set some desired torque. We have both the 210s and the 330s in there in the later phase. You can see that, yeah, all of these were TIMCON beams. If it was a PCS beam, it would be a different color, and it would say PCS here. Okay, so that's basically what the current TIMCON module does for setting beam waveforms. And this is as much information as you get in the TIMCON module, which is just how many beams are on or off, which is nice, but each beam has different amounts of power and different amounts of torque. And so you don't actually know what your power and torque are from this information. And that's basically the motivation behind creating this new tool. Okay. So we're going to calculate the beam power and torque for this shot. We can do it one of two ways. One way is essentially using an IDL routine that's maintained by D3D for these calculations. And the other way is to use those simple voltage scalings that I referenced in the manual earlier on. So you take the actual power and torque from this reference shot and then just scale it based off of voltages or duty cycle changes or something like that. And it's also nice because the reference shot is also important because we're going to plot things like beta and rotation. So I'm just going to make our reference shot the same as the shot that we have the program for. And let's give it some reference time just for kind of a reference beta and rotation. So now that I've got my TIMCON file and I've got my reference shot set up, it's telling me that by bold here, it's telling me that I need to rerun the IDL routines to make sure that my calculations of the beam power and torque are consistent with the shots that I want. So I'll do that. It takes a little second because it has to actually run a bunch of IDL programs for each beam. Okay, it prints some useful information like the voltages and the on times here. And what's actually happening there is this D3D Beams module, which was developed mostly by Brian Grierson and Sean Haskey, is taking inputs for the shot and time, and it's creating these outputs that are power, torque, fueling, etc. And then there's this, it's creating an entire map for each of the 8 beams for its permeance and its voltage, what power it would be. And so then this interface that we have here is just going to basically interpolate along from this 3-dimensional mapping of the power and torque to whatever settings we have. Speaking of settings, we can read, it says, you know, that our reference settings might not be exactly the same as the shot that we chose. So I'm going to reset it. Now it looked at my reference time to get the duty cycle at that time and got the voltages, etc. Okay. So all that's a lot of lead up. But it's got us set up now that we can do some fun things. So the first is just simple voltage scalings. We plot this. You can see points that are the recorded power and torque for each beam in this shot, and then lines that are slices of this power and torque map that we calculated. So you can see the predictions do pretty well. Not exact. And what you can do from this is if someone says, you know, I want a little less power, you can just say, okay, well, the easiest thing to do would be just take this beam that's got at 82 kilovolts, it's got 1.14 megawatts, and I'll bring it down to 65, and that's only 0.7 megawatts. So that requires no change to the waveform. It's easy to calculate, it's robust. So you can do that kind of calculation. When we plotted this, it printed some useful information on the current settings. So sometimes I just put this plot up and then I just reference it if someone wants, if you're close to the target and you feel like you want to make that 0.1 megawatt tweak, you can go here, find a beam that you like, and tell the beamers to reduce the voltage by a couple kilovolts and get the perfect power that you want. But more useful is generally this settings controller. So you can see that each beam has primary settings that are its voltage, this probe voltage, which sets the perviance of the beam, and a duty cycle. And so this is just a GUI interface for setting those things. And what it does is it has those things for each beam, and then it has the power and torque for each beam with a total. And it's using the reference beta at this reference time and a simple power scaling for the beta to tell you roughly what beta you get. So, you know, if I were in this shot and this was the flat top, and then the session leader said, I'd like, you know, beta to be 1.6 now, I could say, okay, I'm going to take the 330 left beam and increase its duty cycle a little bit, and that one didn't quite do it. And then I'm going to increase the 330 right duty cycle a little bit, and didn't quite do it. Didn't quite. There we go. So I just have to turn both 330s on full or something like that. So you can see that clicking around, it changes the values in the GUI. It changes this. You can always see back to the reference value, it's gray, and you can see the individual powers and torques. So this is basically what I do when I'm in the control room and I have a TIMCON set up. You're in the flat top, so I put, you know, the duty cycles that you have on each beam, and usually the whole name of the game is just adjusting those in small tweaks, like you know, you add 25% of the duty cycle to one beam or another beam, etc. And so I play around on this, and then I am on Atom. I have the actual TIMCON module open that's controlling the waveforms, and I would then go in and change the duty cycle accordingly. Any questions so far? So similarly, I could have upped the voltage, you know, on 330 rights to get more power. You got the total power, you've got the total torque. Those are two things that the session leader will commonly tell you to match. And then you've got the beta and a rotation scaled off of this reference time, which again is something that the session leader might tell you to match. So so that's basically the name of the game, between either eyeballing this or you know, manually actually typing it in. And then if you really want to be precise, you say, you know, okay, no one's going to set 93% duty cycle in TIMCON, so let me change that to, you know, 1, and then you can see the plot adjusts and you get a 0.02 difference in megawatts here. So these things are linked, and you can always check the total power and torque. Then you can plot the waveform as well. So this is going to plot the reference shot beta and rotation, and then the expectation with the current beam voltages and things like that. Actually, this is going to plot the reference voltages, so there's the prediction. Okay, so prediction is pretty good. So this is the waveform for each beam, except for instead of like TIMCON where it's just 0 or 1, the y-axis is its power. So you can see the power from each beam, and then you have the power waveform smoothed over some time scale that we set, 100 milliseconds, and then you have the beta waveform from MDS Plus on our reference shot and from a scaled prediction given the power that we have. Ditto for this second plot where they have the torque from each beam, total torque, and scaled. And so then, you know, if I go and set all the voltages to 82 or something like that, and then scale the waveforms based off of my settings, controller, replot that. Oops. I thought it was going to show us more power. Scaled. Well, this is the fun of live tutorials.
You could
Maybe
try
I could-
increasing the duty cycles.
No. No, so unfortunately, so the duty cycle here is not actually changing the TIMCON file, right? So this is just for your reference. Basically, when you're in a phase that you know, like say the flat top, then you can play around with these duty cycles and change the torque that you have in flat top or something like that. But it's not changing the TIMCON file, and so the waveform, you know, the waveform is going to plot this waveform of beams. Well, I won't dig into this embarrassing mistake anymore. But okay, so the last thing that I can try is that you'll notice that my reference shot has the 210 beams counter, and maybe I had this all set up, but then we ran today, and the 210 beams were co. There's a new feature that we just tried to add that says use last shots, tilts, and orientations, and then you can reset the beam map. And hopefully this then uses the ideal routines to calculate the power and torque for each beam, but using the tilts and aiming of the current beams. It requires the last shot to actually be a good shot though. So now that we're not running, that could be a pitfall. Let's see if it worked. Nope. Oh, 0 for 2. Okay. Well, that's that issue I've run into before. If it's not if the last shot was like a power test shot or something like that, then it doesn't have the MDS values for the beams that the ideal routines need. But if it was the middle of a run day and you restored a shot, say, and started it off, and then you wanted more accurate calculations, so you'll notice that that the voltage scalings, the dots weren't exactly on the lines. If you wanted that to be a little bit more accurate, you could then click this box and reset the beam map, and hopefully the calculations would be more accurate given the exact geometry that the settings were on your first shot of the day, for example. Okay, so that's pretty much it. You load in a TIMCON file. You can plot the waveform, but then you can mess around with the voltages and the duty cycles to see how that changes power and torque. Then you have to go into the TIMCON module outside of OMFIT to change the waveforms in the file.
Yeah,
Any
maybe you
questions?
could talk a little bit about the interface between this module and how you would get a file to Atom.
Sure. So OMFIT does have the ability to save the file. But as I mentioned, there's no GUI interface for actually editing the file waveforms. So you would have to go in, either open this file in an editor or go in here and change something, like disable a beam, which I don't currently do very often. But there is on Atom a space that you can see here, Fusion D3D share TIMCon setup files with your username, and then a number of files there. And so that's where, if you are in the TIMCon module and you say save file to disk, then you'll save a file there. So if I didn't want to, so if I was beam operator for the day, and we were going along fine, but I knew that in 5 shots, the session leader was going to want more power. I might mess around with my settings on the duty cycles and come up with a scheme that I think was good, get all the timing just right in the TIMCon module so that the beams don't overlap or something like that, and then save that file to a file. And in that case, I could load a new TIMCon file from the actual file. And then I would need to go to, what was it? Was it D3D Fusion? I just said it. Yeah, Fusion, D3D share, TIMCon, setup files. Really, I should have copied this so I could just paste it. And then Logan NC, and I could load up, some TIMCon file. This is one that I tested out during the run day last week. And then I could plot it. And it has different waveforms than we had there. And then, I can compare. Here, it's a completely different shot, so it should have a completely different torque and power than the actual reference. So you can see that it's got a bunch more power. If any of these beams were set to be in the PCS in the TIMCon file, they would appear as an error bar, and so you would have an error bar in the power. That error bar spans the possible range of PCS powers and torques for that beam, given the minimum on time and minimum off time and the averaging time. These are settings in the PCS. These are the standard settings, and so they're pretty good estimates. And that's useful for knowing if you're giving the PCS enough beams to play with to meet the power target that you want, or the beta target that you want, for example. I should have come up with a shot that had that before doing this, but if anyone has one off the top of their head, we can plot it. No.
I think the one in the Google Doc tutorial 170063 has a PCS beam.
Doesn't look like it. But this brings up a good point that when you do these plots, it does plot the voltage and the time limit at that voltage for each beam, and then the on time in the TIMCON file for each beam. So this is telling me that this TIMCON file is pushing the on limit time for these beams here. They're probably going to time out. It's orange if it's greater than 80%, red if you're at or above 1. So we have more time to turn on 330 left. We could up that duty cycle, for example. Okay, that covers most of it. I would say that the only other thing is that if you want to do a deep dive, if you're sitting in your office a week before an experiment because you're super prepared and you're not leaving things to the last minute, you can always dive into this D3D Beams module itself. It has a whole bunch of information. You can compute the power, scan things. It has each beam and all the settings for each beam here, with even more settings exposed to you. So, the neutralizer flow rates, source flow, efficiencies, and calibrations, etc. It has on times, powers and torques for all the different beam settings, etc. It also has a very nice plot. Here, which is very similar to the one on the larger TIMCON module, but it has all the individual beams as well as the total power and torque, for example. This is a fun map of the settings. So sometimes you can use this, if you just want to know what were the voltage settings for the beams on some past shot. You can make this plot and there they are. Or dig into this module. I mean, alternatively, of course, in the TIMCON module, if you load it as the reference shot and then reset to reference settings, it'll tell you the voltages that shot was set to. Okay, any questions, any suggestions for improvement other than fix the waveform that didn't work?
I don't see any hands. Yeah, I mean, it's an evolving tool and we want it to be useful for people that are doing beams in the control room and for planning. So give it a try and let us know what you think.
Yeah, I find it useful.
If I can just say thanks, guys, for putting this together. We'll definitely, I think I'll at least have more feedback after I use it a bit, both to prepare and in the control room itself.
Yeah, absolutely. Give it a shot and feel free to shoot me an email if anything is confusing or if you see low-hanging fruit for improvements.
Yeah, we'll do.
Sweet. All right.
Okay.
I think I can stop sharing.